Okay, so we are talking about section journal physics, our first section. And last time we have done with mass and weight topic. Because I not started the topic motion because I know many students start session after Eid. So that's why I started a very short topic that is very simple mass and weight. And I also have recorded lectures of those topics. And I also shared the PDF files with you, those who joined me new in the group. And today we will start with a new topic. That topic is known as moments. Basically, that is related to force, not very deep topic because it is a specific part, or we can say that a very single part or a single concept related to a force, right? So today we are going to talk about moments, or in simple words, if we write for moments, we can say that moments is the turning effect of forces, right? Let's suppose. Okay, so basically, whenever we apply a force on any object, right? Let's suppose if there is a box and when we try to push that object or try to pull that object, so normally that object displays from its original position, right? That is a common simple example of our daily life, right? But today we are talking about a topic that is related to the turning effect, just like the example of a door, just like the example of a seesaw, or just like the example of a scissors. So these are the objects in our daily life on which when we applied force, so they don't displace from their original position, they starts to rotate about their fixed position, right? Just like if we take the example of a door, we are talking about the turning effect, which is related to the forces. So let's suppose if we are talking about a door, we have a very common example in our daily life related to that topic moment. Okay, so we know that whenever we apply force on the door, so door is fixed. Let's suppose this side of the door is with the wall, and try to apply force on the of the door. Let's suppose we are apply force on this side. This door starts to rotate about its fixed position, right? So
Yes, sir.
basically, yes. So basically, this is the concept of turning effect of forces. In this whole section or in this whole chapter, we are only going to talk about the turning effect, not the displacement of the object, right? That is a separate chapter of forces. This is only related to the turning effect. Okay. So now whenever we are talking about the turning effect, so normally we categorize them into two category, either clockwise or anti-clockwise, right? Because normally we need some terms to relate the motion of an object, to explain the motion of an object. So normally when we are talking about the turning effect of forces, so we consider two types of motion. First one is clockwise, the second is anti-clockwise, because paper and 2D diagram are only able to explain the motion of an object in 2D diagram, not in 3D. That was difficult to explain. So that's why types of rotation. The first one is rotation, the second is anti-clockwise rotation. And there are some also factors. There are multiple examples in our daily life. One we already mentioned, the example of door, and the example like the example of seesaw, or the example of example of pliers. So all these type of example are related to the turning effect of forces or moment. So both are the term. Moment is the scientific term, and in simple word we can say that we are talking about turning effect. Okay. So since we are taking the example of a door, let's continue with the example of a door. So one thing we already observe in the example of a door, that there is a fixed point on the right hand side. This is the fixed with the this is a fixed point. Yes, I will also provide the complete notes. Lastly, we only discuss about one topic, mass and weight. And I also have the PDF of that, so I will again share in the group. And all links are mentioned in the description of the group, so you may access anytime. Okay, so when we are talking about a fixed point, so we need a scientific term which is related to the fixed point, because we are not going to use the word fixed point. We use a term that is known as pivot point or simple pivot. So basically, pivot used for a fixed point whenever we are talking about any example, because in this topic we are going to solve different type of example in our daily life. So that's why first of all we need to find the pivot point. Pivot is a very important concept in this moment, because first we need to know about the pivot point. Just like if you take the example of your elbow, so if you take the example of your elbow, so basically elbow is your pivot point, and you can turn around your hand according to that fixed point or according to that pivot point. So just like the elbow, there is a pivot or a fixed point in every object when we are talking about moments or turning effect, right? So take the example of the elbow, and there is a joint in elbow that gives you a rotation, clockwise or anti-clockwise rotation, whatever you try to move your hand in any direction. So basically elbow is our pivot point, right? So same goes for the door, same goes for the seesaw and scissors. So one more important thing, that we got a new term. Okay, I will tell you at the end of the class that how many lectures we have done. I will also send you the recorded lecture link and the notes, right? So we have only done with one chapter, that is mass and weight. So that's not very much difficult. That is mostly theoretical base. Okay, so you got the concept of pivot point, right? So whenever you are going to solve the question related to moments, so first of all, you need to find out the pivot or the fixed point. Next thing is, let's suppose normally in our daily life, when we are going to apply force on a door, so normally we apply force on the knob of the door or the lock of the door, right? So this is the point where we are going to apply a force on the door. So basically there is a distance. If we mark this distance from the force of or the line of action to the fixed point, so basically there is a length or there is a distance between the point. This is a point where we are going to apply the force on the door, or this point is also known as line of action. This term is not important, line of action, but this pivot term is very much important. So most of people write just a point where we are going to apply the force. Most of the people used to write line of action. So there are different terms. So that's why line of action term is not much important. Pivot is important term. So let's suppose if we are going to apply a force on any specific point on a door, and we measure the distance from that point to the pivot point. So this is the distance which is marked with a small d, right? So in daily life or in normal physics, we use a small d for distance or displacement, right? But this time we are also using this for a distance or a length, but there is some different term related to the moment that is used for this symbol d. So first of all, I am writing the formula for the moment, and I am also writing these symbols in that formula, and then I will explain that what is the meaning of that symbol. So basically whenever you are going to find the moment, so basically moment is the product of force and moment arm. So very simple definition related to the moments, because they don't ask about definition in exam of moment, so that's why it is not much very important. So the product of Acha, recordings, I will send you the recordings, so don't worry about it. I will send the recordings after each class. So basically product of force and moment arm is known as moment, and is capital M is the symbol for moment, F is for the force, and D is for the momentum. So basically, normally in physics, we use a small d for distance or displacement, but now this time we are using a d for distance or displacement, but there is a different concept because we know that we are talking about turning effect. So that's why we represent d with momentum. So basically, there is a new term for small d. Symbol remains same, concept remains same, only term is different in turning effect, right? So basically, D represents the momentum, just like the example of our arm
Wait,
or
sir, I have a
balance.
question.
Yes,
D is the distance between the fixed point and the line of action.
yes, and that
Okay.
is and that distance scientifically known as momentum. In short, we just write momentum, right? And when
Okay.
someone asks that what is momentum, so you just simply write it is the distance between the line of action and a pivot point, right? Because when we are going to
Yeah.
solve questions, different lengths are given in the diagram, so that was very difficult to identify that. So that's why momentum is a separate term. The concept of momentum is something different from length, right?
Yeah.
And when we are going to write the SI unit, so for SI unit, that is not much very difficult. The SI unit for the moment is the force. The SI unit for force is Newton, and momentum basically is a distance, so we know that meter is the SI unit for distance. So Newton meter is the SI unit. Very simple. Newton meter is the SI unit. Capital M is the symbol for moment. So the SI unit for the moment is Newton meter. Right? Any confusion?
No, sir, no confusion.
Okay. Okay, one more thing. In few concepts or in few definition or in few question, you will find a term like this. I will write it in a separate site so that will be clear for you. Let's suppose if we are writing for the momentum,
Sir,
yes,
can we call the moment arm the perpendicular
yes,
point?
I am going to
Okay.
talk about that one because most of the time in many books or in many concepts, they are writing a perpendicular distance. So basically, a momentum is a perpendicular distance. I will also explain that it is a particular distance between pivot and a line of action. So basically, there is a concept of perpendicular distance. We may also write a distance, but there is a concept of perpendicular distance. Why perpendicular distance? Let's suppose if you take a length on the door, let's suppose this is small d, which is already mentioned over there. Let's suppose this line is on x-axis, right? Horizontal line. And whenever, or let's suppose if you try to open this door, right? So just like the book, let's suppose if your book is closed and when you try to open your book, so that book basically opens in upward direction, right? So the cover of the book is on horizontal surface, and when book tries to open, so eventually you got a 90-degree angle, right? Same goes in a 3D manner. Let's suppose if you consider a door in your daily life, and when you try to open the door, so basically the surface of the door is in front of you, and when you try to open the door, so basically doors open in the perpendicular direction. Basically, let's suppose D is the momentum, right? And let's suppose if you try to open a door, so this will be the direction, right? When we try to pull the door, so we pull the door in this
Yeah.
direction. And basically this is on z axis, right? The 3D diagram, or we can say that on the third axis. This is not on vertical or y axis, this is on z axis. It means this door is coming out from the screen, right? Just like the 3D diagram, that something, or 3D movie, that you feel that something is coming out from the screen. So that is basically z axis, right? Any confusion?
No, sir.
So basically, that's why we use a perpendicular concept, because this is on z-axis and momentum is on x-axis. So we will get a 90-degree concept over here. So that's why we use the concept of perpendicular distance. But that is not much very difficult, or that is not much very compulsory, because they don't ask about that how it is perpendicular or explain how it is going to be perpendicular. But in many books or in many definition you find this word, that perpendicular distance. So that's why I explained over here, so you will not get confused that what is the concept of this perpendicular condition. Okay, so now there is a very common or very important concept in this topic moment, because 99% questions are related to that concept. They are not going to ask about definition, they are not going to ask about any diagram. The question that is going to be asked in the exam, which is related to the principle of moment. So we need to know about the concept of principle of moment. So our main focus is on principle of moment. This is one and only concept in this whole chapter that is going to be assessed in your exam, and that is very important, and sometimes it is going to be very confusing, because when we are going to solve different questions related to it, so then you will realize that sometimes it was very difficult to solve. In simple word, let's suppose if we consider a seesaw, before writing the principle, let's suppose if we consider example of a seesaw. We are having a seesaw, and let's suppose if we consider there are two objects placed on this pivot point. One object is placed over and object is placed over here. And when we are writing turning effect of forces, so it means there are forces involved in this diagram. So how forces are going to be involved? Let's suppose if this is object, it also has some mass, it also has some mass. And the force, or we can say that the weight is going to act in downward direction. This object, let's suppose the weight of this object acts in downward direction. So we will get the force, or the force of first object, and we will also get the weight in downward direction, that is also in the category of force. So basically there are two forces acting on seesaw, right? Let's suppose first, if we ignore the second body, if we only consider the first body, ignore second one. Let's suppose there is no second body placed on seesaw, only one object is placed on the right hand side of the seesaw. So what happens next?
Oh, wait, sir, can you repeat?
Yes, let's suppose if only one object is placed on the right hand side of seesaw, that is F1. There is no F2, there is no second object. So
It
what
will
happens?
turn clockwise.
Yeah,
It will turn clockwise, right? It means
yeah.
we are getting turning effect of force, right? In clockwise direction, like this.
Yes.
If we are talking about body one, and now ignore the first body and consider the second one. So we will get the opposite direction, like this, anti-clockwise, right? Okay, so these are two different observations, right? For individual body. But what happen if both bodies have same mass and same distance from the pivot?
There'll be no turning effect.
No turning
Equilibrium.
effect. Yes, equilibrium. So basically, seesaw will be in equilibrium. Equilibrium means basically rest state and equilibrium state. Both are different. We are going to use a term equilibrium in principle of moment. I am first writing the concept, that what is the principle, then we will discuss what is the concept for equilibrium state. So principle of moment will be like this: in an equilibrium state, sum of clockwise rotation will be equal to sum of anti-clockwise. We are writing sum because sometimes we have more than one object on single side, right? Or sometimes it happens like this: one object is on one side and three bodies on the other side. Anti-clockwise rotation. There are definitions. You may consider any one of your choice. So basically, there is a difference in equilibrium and rest state. Equilibrium state happens when we are applying force on an object, but still object is not moving or not rotating, right? And we know that there are two forces acting on an object, but still object is not rotating or turning about its fixed point. So that is the state of equilibrium, right? And when we are not talking about the forces, so then we can say that object is in rest state. So that's why we use different terms like equilibrium state or rest state. So that is the concept, right? Any confusion?
No.
No, sir.
No, sir, no confusion.
Okay. Okay, so formula remains same, F into D, right? But conditions are different. Let's suppose if we consider this example, this is example number one, let's suppose. So basically there are two objects acting on on an seesaw, right? So basically there are two objects. So whenever we are going to solve the example, so we use formula like this. Basically there are two objects. One object tries to rotate seesaw in clockwise direction. This is clockwise and this is anti-clockwise. So we just use principle like this. So the formation or the equation of the principle will be like this, that moment acting in clockwise direction will be equal to the moment acting in anti-clockwise direction, right? And we use the formula that F1 D1, let's suppose, and you may number or you may just number the forces according to your choice. There is no hard and fast rule to number or figure the marking on the object on the seesaw or any other example. So numbers are in your choice. You may write one for the clockwise rotation or you may use one for anti-clockwise rotation. It's up to you. So we just used to write the formula like this. Anti-clockwise rotation. Basically, I'm writing in short. CW means clockwise rotation and AC means anti-clockwise rotation. So just for the short, because we are not going to write in the exam, we just need to solve the question. Okay, now let's try to solve a question related to this principle of moment. Then we will got the idea that how questions are going to be included in our exam. I will show you the questions and different conditions, because this topic is much more related to the practice of the question, because there is no theoretical concept you need to remember. There is not such a formula or such equations that was very difficult for you. Just a single formula, only concept is very much important. And let's see that how the questions are going to be. Principle of moment. Dynamics.
Sir, do we answer you in chat or just here?
It's up to you. First I will explain you the concept that we are going to solve the question. Then you may answer or you may also try to solve on your notebook, because there are some calculations included in that. Okay, so let's suppose first of all you need to know that how, or we can say that what are the steps to solve the question, because many students are confused in that concept, that how we are going to identify the forces or how we are going to mark the direction. So that is a difficult part for some students. So first of all, let's suppose this is a question, right? The statement mentioned over the question same is in the diagram, right? So I'm not going to read the question. You just need to find out the upward force F, which is already unknown over here, right? So the very first part for the question is, first you need to identify the number of forces, right? Because number of forces give you the concept of moment. So first of all, we need to find out that how many forces are there. So how many forces are there in this question? Three forces.
Three forces.
Three forces.
Yeah, three forces.
Okay. So you may mark forces according to your choice, right? Let's suppose I'm marking from left hand side. So I'm writing F1 for this one. It's up to you. You may mark according to your choice. That is not compulsory. This is F2 and this remains unknown F, right? No symbol for this, only F. This is F. We are going to find F. So first step is very simple. You first need to identify the number of forces. Second step is
Sir, I
you,
wanted to ask that the formula for D, we use meter, right? Over here is centimeter. Do we need to convert or not?
yeah, I will explain that you need to convert it or not, because normally we use length in meters, right? But if all units are in same like centimeters, so you are not going to convert them into meter, because both sides are length. So when we are going to divide the terms, so it will got cancel out, right? So that's why it's
Oh,
not a difficult task. If units are different, let's suppose some are mentioned in centimeter, some are mentioned in meter, so then you need to convert and you make to them in similar form. But otherwise, if all are mentioned in centimeter, it's okay. And second important thing is you need to identify the rotations, that how many types of rotations are there included in your question. So let's suppose we started from F1. So first of all, starting from F1, so what is the rotation for F1? Either it is clockwise or anti-clockwise. So to identify the rotation, this is important part. For this, you first need to find out the pivot point, right? So where is the pivot point?
The center.
Center. So I first choose a simple question, that first you got all the concept that how to solve the question. Then we find a different question, that sometime pivot is on the corner and we are confused that where is the pivot point, and we normally choose the center. So pivot point is not always at the center, it may be anywhere. So basically, pivot is our center point. So according to that, okay, so in your exam, if you got confused how to find the rotation, so there is a very simple way to find out the rotation. Let's suppose if you have a ball pen or a pencil in your hand, and on a screen, just place a one corner or a tip of a pencil on the pivot point. So just simply horizontally place your pencil or the point of your pencil at pivot point, and try to uh, apply force on pencil in the direction of force. So what is the direction of force? In downward direction. We are talking about F1. So basically F1 is acting in downward direction. So when you try to apply force in downward direction, so let's suppose if I placed pencil over it, let's suppose I have a pencil and I used to place it over here. Okay, so if it was difficult for you to identify the direction, so simple task is just place a pencil or pen, anything, and just hold it over here, because this is our pivot point. So you need to hold the pencil from this point, right? And try to apply force in this direction, because F1 is acting in downward direction. This is acting in downward direction, right? So what will be the rotation of an object? Is it clockwise or anti-clockwise?
and
This pencil will rotate in this direction like this, right?
yes,
So is it clockwise or anti-clockwise?
it's anti-clockwise.
Anti-clockwise. If someone find it difficult, you may ask it again. You may try by yourself, because that is, we can say that that is a very general knowledge concept, right? That is, there is no type of physics involved over there. You just need to find out in which direction it is going to rotate. Okay, let's check the answer also. Okay, one more thing, whenever you are going to identify the rotation for individual object, ignore all other objects, right? Only consider one force, right? So is it clear for everyone that the first force is acting anti-clockwise in anti-clockwise direction,
Yes,
right?
sir. It's clear.
Okay,
Yes,
It's clear.
sir.
okay. And now let me know the second F2 and the unknown F. So this will rotate in this direction because pivot is in center, right? So now we need to
Yes.
place our pencil on the other side.
Yeah.
So this will be
It's
clockwise.
clockwise.
Yes. And what about this F? The unknown
Anti-clockwise.
Anti-clockwise.
anti-clockwise. Nice. So only this part is very difficult for some students, that how to identify the direction. Because if you are not going to identify correct direction, your formula is for no use, because you need to place in clockwise section or anti-clockwise section. So basically now we have two anti-clockwise force and one clockwise rotation. So now you need to write the formula like this. Let's suppose I have first write the clockwise rotation is equals to the anti-clockwise rotation. I'm writing this in short just to solve the question, right? There is no specific short term for these clockwise, anti-clockwise, right? So don't get confused in this. So we have only one clockwise rotation and that is mentioned with F2. So we know M2 is on the left side, M1 plus MF. M means the moment. So the moment of second body is equal to the moment of first body plus moment of unknown force, right? And we expand the formula, so that will be like this: F2 into D2, F1 into D1 plus F into D. So we already know the values of F. We just need to write the values of D, and that is also very much simple. There is not a difficult task. For F1, we know that this will be D1, right? The distance from the pivot to the line of action. Sorry, yes, this will be D1. And 30 will be D2, right? Again, from the pivot to the line of action. So F2 is 60 multiplied by is equals to F1 will be 30 and 1 will be 40. F is unknown. And what is the value of D? The moment arm for this force, which is unknown.
50.
50.
50.
50. Yes. Most of the student confusing this 20, right? But always remember, you need to find out from the pivot point. So from the pivot point, you need to choose this whole length over here is equal to 50. 50. Now you just need to do calculation. That is simple mathematics. And one answer I got from one of your student, that is from Umair, that is option C.
Sir, I got B.
B.
Never mind, sir. Sorry, I'm gonna redo my answer. 1 second.
Okay. So 60 multiplied by 30, and we need to subtract.
Yeah, sir. I'm getting B. 12 newtons. 12 newtons.
Same.
Yes. So we will got
Yeah,
6.
I confused the 20 centimeter for 50.
Okay. So we are getting option B, 12 Newton, right? Okay, one
Yeah.
more thing. The question you ask in the start of this question, that is we need to convert in meter or not. Let's suppose if you convert into meter, so that is useless, right? Because we are having all length in same units, right? So if you convert into meter, so final result will also you get 12, right? So that is additional step that you need to convert into meter. So that's why it is not compulsory, right? If all units are in same
Okay.
form, so that is not important, because this question is already lengthy and we are solving MCQ, right? And we know that in IGCSE we only have an average 1 minute to solve one MCQ. In O level we have much time to solve question, but in IGCSE you know that we need to solve one MCQ in 1 minute maximum. So that's why unit conversion is not important, right? So any confusion?
No,
No,
sir.
sir.
Basically this is a complete concept of moment. There is nothing involved in this section of moment. There are some topic related to equilibrium, and that is So I will explain that with the center of gravity, because those type of concepts are only asked for 1 mark in your exam, but this question is a detailed one. So you may join back with me same link, right? So then we try to solve some other questions too, right?
Okay, sir.
So